For day 4 notes, example 1, it says, does the table represent a linear and exponential function or neither? And explain why. So for the first one, we're going to look at the y column. And we want to know what kind of pattern exists between 7, 9, 11, 13, and 15. And so I first want to look and see, okay, from 7 to 9, it increases. Well, how much does it increase? It increases by 2. Okay, so I know that it increases by 2. Okay, from 9 to 11, it increases by 2. 11 to 13 is the same, by 2. And from 13 to 15, it increases by 2. Okay, now since it's increasing by 2 each time, and we're adding, that means that it is linear. So for the explanation piece, we're not going to write that out, but you need to know that linear is when you add or subtract in that y column. Okay, increasing or decreasing in the y column, adding or subtracting. Then for B, we look, okay, we're looking at that y column again, from -1 to -3. How can I get there? Well, I could subtract 2, right? But from -3 to -9, that is definitely not subtracting 2. That's like subtracting 6. So we know that we're not the same. So we have to do something different, since those two numbers were different. These numbers were different, so I have to do something different. So now I need to try multiplication or division. So from -1 to -3, how could I multiply or divide to get here? Well, I can multiply by 3. So -1 times 3 is -3. Well, would that work for this one? Does -3 times 3 equal -9? Yes. -9 times 3 is -27. And -27 times 3 is -81. So if you multiply or you divide in the y column, then that is considered exponential. Alright, so now, again, same method. Start with the addition or subtraction. From 5 to 6, we increase by 1. From 6 to 8, we increase by 2. Well, these are different. So now let me try multiplication or division. So 5 divided by anything get me 6? No. Does 5 times anything get me 6? No. So since I can't add or subtract the same number, and I can't multiply or divide, then I have to say that this is neither. Alright, for example 2, we are just plugging in 3 for the x in the expression here. So 4 to the 3rd power would be 4 times 4 times 4. So that's 64. Here, 3, put a 2 in for x, so 3 squared is 9. Down here for these two, we've got 3 times 5 to the -2 power, because that's my t. But we know we can't have negative exponents, so we're going to put this over 1, and we're going to bring down the 5 only. But it does say that we need to evaluate the function. So 5 to the 2nd power is 25. And 3 over 25 cannot reduce, so that is my solution. Okay, so again, same method. We've got 2 times 4. T is a -3, so it's to the -3rd power. 4 to the -3rd. I'm going to bring to the bottom. We figured out 4 to the 3rd up here, and that was 64. So we have 2 over 64. Now, this can divide by 2. It can reduce. So 2 divided by 2 is 1, and 64 divided by 2 is 32.